Today's notes should be short and sweet. We're going to talk about trapezoidal method and average value of a function. To talk about trapezoidal method, we first have to remember what a trapezoid is. A trapezoid is a four-sided figure in which exactly one pair of opposite sides is parallel. Okay, like that, or you could see one side could be vertical like that, where the other sides are perpendicular to it. But either way, we see that one pair of opposite sides is parallel. Okay, taking away the arrows there, we can label those sides as those parallel sides as base 1 and base 2, and followed by the height. Okay, the height of the trapezoid. Whereas the area, then, we can write that as 1/2 multiplied by the height, and multiply that by the sum of the lengths of the bases. Okay? Now watch, I'm going to do something kind of tricky. So I'm going to take this trapezoid here. So I'm going to fill in the area. Okay? I'm going to take the trapezoid and I'm going to turn it on its side. So look at this. Okay? So I've got a trapezoid that, again, I turn on its side, or I should say on its end, where if we label that trapezoid, we can see the base 1 and base 2 are now the vertical sides. Whichever sides are parallel are considered to be the bases, base 1 and base 2. And take a look, the height then is the distance between the two parallel sides. Okay, so that's pretty tricky. Maybe if you didn't catch that, rewind the video. Okay, so the area of a trapezoid remains the same whether or not the trapezoid is on its end or just kind of flat and horizontal like we normally see it. Okay, so enough for the sarcasm. Let's get to it. All right, we're going to be approximating. Here's the way the problem lays out. Is this graph that you see here is the graph of y equals x squared. Okay, what we're going to do is we're going to approximate the integral from 0 to 2 of y equals x squared dx by using the trapezoidal method and by using trapezoids, areas of trapezoids, and we're going to use two subintervals, and the subintervals, let's say, have the same length. Okay? Alright, so we could easily find the exact area here, but this just gives us a good example to start with. So what we really want to do here is want to draw two trapezoids, and probably shouldn't have done that. Let's do this first. Okay, let's take a look at our intervals. We have 0 to 2, and we know that from 0 to 1 is our first subinterval. And so I would just want to draw a line there that represents from 0 to 1 on the x-axis. So draw a line segment, I should say, there. And then from the left end point of the line segment of our first subinterval, I just draw a vertical line up till I hit the graph. Well, there's nothing to draw there because we're already on the graph. Then at the right end point of the first subinterval, we're going to go up till we hit the graph. And we stop, because we can easily figure out how high that is. And then we're going to draw a line segment that connects the ends, just like that. Okay? So that's our first. Now, I know that that's our first trapezoid, but in fact this one happens to be a triangle. And that's okay. Sometimes our trapezoids, when we're using a trapezoidal approximation, are going to turn out to be triangles. Our next subinterval goes from 1 to 2. So at the left end point of that subinterval, we go up till we hit the curve. Okay, we stop. We know how high that is. And then from the right end point, we go up till we hit the curve, and we know how high that is. Then we connect the tops of this figure here to make a four-sided figure, and there we could see our trapezoid. And that's almost exactly if we find the area of that trapezoid, it would be almost exactly the area underneath the curve that we're looking for anyway. So all we have to do is come up with the area then of each of these trapezoids, and by using the formula, and we just add them together and we have our approximate area under the curve, so we are approximating this integral. Okay, so I actually want to do this. I want to erase this stuff here so I can rewrite it over on the left so I have a little bit more room to work with. So I have the integral then from 0 to 2 of x squared dx, and that's approximately equal to the area of each of these trapezoids. And let's do this. Let's label the area of the first one A1. That didn't come out very well. Let's put that in red. A1. Okay, and then in green we have A2. So we have the area of the first one plus the area of the second one, and so we'll write that like this: A1, area of 1, plus the area of the second trapezoid. Okay, well, the area of the first trapezoid is just the area of that triangle. So we can use the area of the triangle formula. We have base times height, so 1 times 1 is 1, so we have 1/2. Now if we wanted to use the area of the trapezoid formula, we would go 1/2 times the height. Remember the height which we talked about? Even if it's on its end, the height, then we can still find it. The height would be the length of the subinterval. So the height then would be 1, and then multiply that by the sum of the lengths of the bases. Okay, well, 1 squared, we know the height of the first f of 1 then would be, f of 1 would be 1, and f of 0 would be 0. So we have 1 plus 0. Well, 1 times 1 is 1, and 1 times 1 times 1/2 is 1/2. So anyway, that whole thing is going to be 1/2 anyway. Okay, plus. Now let's find the area of the second trapezoid. The area of the second trapezoid is 1/2 times the length of the subinterval, okay, times the sum of the lengths of the bases. And the length of the first base, which would be f of 1, we know that f of 1 is 1 squared. We know that f of 2 is 2 squared. So we have our exact value of our trapezoidal approximation. Shouldn't say exact value, but our trapezoidal approximation would be 1/2 plus, and then we have 1/2 times 1, which is 1/2, and then 1 squared is 1 plus 2 squared is 4, so 1 plus 4 is 5. So we have 1/2 plus 5/2, and that's 6/2. So we have 3. 3 is our trapezoidal approximation with n equals 2. I forgot to put that. N equals 2. Okay, so we find the area of each of those trapezoids. That's it. That's the trapezoidal approximation method. Okay. One last thing to mention here, is that approximation too high or is that approximation too low? Well, this is different than the RRAM and the LRAM. The RRAM says if the function is increasing, then the RRAM approximation is too high. Okay. Well, the trapezoidal approximation, if you notice here, we have the function is concave up, so the approximation using trapezoids will be too high. Okay, too high when the function f is concave up. So we say too high because f is concave up. Now it needs to be concave, yeah, concave something, concave up. The function needs to be concave up over the entire interval, otherwise you won't know whether it's too high, the approximation is too high or too low. So but that's a good thing to keep in mind. That's that extra point that you'll get on the AP exam. All right, so let's go ahead and take a look at this next one. I want you to approximate, so this is your practice problem, approximate the integral from 0 to 4, and I will only make you do 2 subintervals, so we're n equals 2, okay, 2 subintervals, of this is the square root of x, dx, okay, so we have y equals the square root of x. Alright, so use your trapezoidal approximation to approximate that integral and then let me know whether it's too high, your approximation, too high or too low. Okay, so pause the video and then play it when you're done. And here you go. You have two subintervals, so there's the first one. Go up till you hit the curve. There you go. And then we have the next subinterval, two subintervals. Go up till you hit the curve. Go up till you hit the curve, and there you go. So the area of this first one, and I'm just going to use my area of a triangle since you saw how I did it the other way. So we have 2, so we have 1/2 times the base, 2 times the height. Now the height is, remember, the y, the height, depends on what x is. If x is 2, then the height is the square root of 2. Okay? And then we have plus, now the red, okay, the red trapezoid. The red trapezoid has an area of 1/2 times the length of the subinterval, which is the height of the trapezoid, which is 2. And then we have multiplied by radical 2, which is f of 2, so the height of the left side. And then the other base, I should say, the base 1 is radical 2, base 2 is radical 4, which is 2. And do we have a good way of expressing this? We have 2 goes into 2 times, or 2 goes into 2 one time. 2 divided by 2 is 1. And then we have radical 2 plus, and then these 2's cancel, and we get plus radical 2 plus 2. So we get 2 radical 2 plus 2, which is our end result. That is our approximate value of that integral. And let me pause here real quick. So I just paused because I wanted to find out the actual area. So this actual area of this integral is 5.333. 5.333. By the way, we should have also mentioned that the integral is, or I should say the trapezoidal approximation is too what? Too what? Too low. Yep. That's right. This is too low. And the reason why it's too low is because f is concave down. Concave down. Therefore, too low. So let's put it all in there. F is concave down. Therefore, the approximation is too low. And by the way, the approximation was 4.828. So this is about 4.828. And again, you can see that it's too low. But we know that it's too low because f, again, is concave down over that interval from 0 to 4. All right. So that's 13 minutes, and I hope that the next video is not 13 minutes, but I thought that this wouldn't take that long. Anyway, there's a lot there, but it's a basic, simple method of finding, approximating a definite integral. So hopefully that helps, and I'll see you in class. Actually, don't forget to watch the next video.